Thank you. I'm honored to be here today to talk with you about PFAS. All right, so first, I just want to give a quick overview of the Water Quality Association, who we are, what we do. Does this screen actually work?
Yeah.
Nope. So we are a not-for-profit association that represents the residential, commercial, and industrial drinking water treatment industry. Our mission is to be an advocate for the betterment of water quality. Oops. No, I have nothing. But I have. Technical difficulties. All right, here we go. Yeah, we operate a product certification program as well as a professional certification program. Our expertise really comes from the treatment strategies that you would use in a home or a building. And my background is chemistry. I'm a chemist and analytical chemist. Before I joined WQA, I spent about 20 years in the analytical testing industry. So whether we're talking to a consumer or a water treatment professional, we always stress that the first step is to test your water. And this is a challenge with PFAS because, as Marty reported yesterday, it's cost prohibitive, right? The single sample can cost you $300 to $600, plus the lab's going to recommend a duplicate, maybe a field blank, maybe the private well owner wants to do some post-treatment testing to make sure they're not getting any breakthrough. All these things quickly add up to, you're spending thousands of dollars more than the average private well owner wants to spend on testing. In fact, maybe more than they need to spend on treatment. So I want to bring your attention to this study that was done in 2019 by the National Institute of Environmental Health. They set out to develop a new media for the removal of PFAS from drinking water, which they did do along the way. But more exciting to me, they invented a new approach to testing for PFAS. Now, this is not an approved drinking water method. It's just a method that they invented along the way when they were developing their media. It tests for 55 different PFAS down to 1 parts per trillion. They've done side-by-sides with urethans and gotten really accurate results. So it does give you reliable results. And it was originally marketed under the brand CycloPure. That was a startup that they were just using to market this test. But it has caught on, so you may find it now under other brands as well. But the way it works is they send you a cup. And at the bottom of this cup is a filter paper. So you put the cup under the faucet, you fill up the cup, the water drains through the filter paper, you ship the filter paper back to the laboratory, they desorb it with a solvent, and then they directly inject that concentrated PFAS solution into their instrument. So it's a super simple sampling method. The kit comes with everything you need, including the disposable nitrile gloves. You don't have to ship water around. And as an analytical chemist, I can tell you that it doesn't get any simpler than, desorb with a solvent, direct inject concentrated solution. That is, that's the simplest method you can possibly have. So it is definitely a paradigm shift when it comes to the approach for PFAS testing. And normally as an analytical chemist, I would not recommend you look at alternative methods. My message has always been, go to a certified drinking water laboratory. They're going to use an EPA approved method. That's where you're going to get your best results. But in the case of PFAS, I do recognize that we need something different. The current methodologies just are not addressing the needs of consumers, especially when it comes to private well owners who just want to know, is PFAS in my water? Or is my treatment system working, right? So this is something you might want to consider. Some of our water treatment professionals have used this test and done their own side-by-side testing. If you guys do your own side-by-side testing, I'd love to know how it comes out, and let me know if the results are good or not. From what I've seen so far, it's pretty good. And all of their data is published. Their side-by-sides are published, so you can review them yourself and make your own decision. But it's much cheaper and easier compared to the other methodologies. So what is PFAS? When we talk about PFAS, this is a term that refers to per and polyfluoroalkyl substances. So it's a whole class of chemicals. It's not just one chemical, it's a class of chemicals. And the two that we know the most about are PFOA and PFOS. Both of those were voluntarily phased out of production in the US by 2015, although they still can be imported. The industry around 2001 started developing alternatives to PFOA and PFOS. This slide shows an alternative, for example, to PFOA. And what they've done is just drop one of the carbons from the chain. And so it probably doesn't take a chemist to look at this and say, it's likely to have very similar chemical properties, which obviously makes it useful. That's why it's useful as an alternative to PFOA. But unfortunately, it's also likely to have similar environmental concerns and public health concerns. So there was a lot of this that's been going on since 2001, and there's many different ways you can modify these compounds. You could, what happens if I drop a fluoride? You could drop a fluoride or two. You can change the functional group on the end, and of course you can lengthen the chain, shorten the chain. So the question now is, how many PFAS are in use? How many are out there? How many have been invented? These are all man-made chemicals. They don't occur naturally in nature, so these are all man-made, but how many are out there? And there has been, to complicate that question, there has been an ongoing discussion in the world of chemistry about what is PFAS. I said it sounded very simple when I said it, per and polyfluoroalkyl substances. But as a chemist, I can tell you that chemists enjoy vigorous conversations about nomenclature in the way that you normal people enjoy vigorous conversations about politics and religion. So I wouldn't look for this to be resolved anytime soon, but I bring it up because there was a globalized definition published around 2021, and that definition was endorsed by the American Chemical Society, so it has gotten some traction. PubChem, which is one of the largest chemical databases in the world, they've adopted it, and according to PubChem has currently identified over 7 million PFAS and counting, using that new definition. I would say a more conservative estimate would be there's more than 15,000 of these chemicals in use. And good reason to believe there may be a heck of a lot more than 15,000. But bottom line is there's a lot of these things out there. The EPA tried to regulate 6, okay? Just 6 of those. That has been a huge ongoing battle. They are being sued. The lawsuits are still going. Just last week, they announced, okay, we're going to back off this. We're just going to regulate PFOA and PFOS, drop the other 4, and we'll push the compliance deadline out to 30/31. So bottom line is there's a lot of these things out there. They have made it into the environment. They've already made it into our drinking water sources as well. And unfortunately, the EPA is never going to get ahead of it by regulating 1 or 2 at a time because there's continually new ones being invented. So it's something that's going to be in our drinking water for a while. The good news is it's pretty easy to use in-home treatment to remove PFAS from your drinking water. There are both point of use and point of entry solutions. Point of use would be what we refer to as a treatment strategy that you're going to use at the point of consumption, whereas point of entry would be something you're going to use to treat all or most of the water in the home. So the 4 that I'm going to talk about today are reverse osmosis, carbon filtration, anion exchange, and some of the new proprietary medias. So starting with the reverse osmosis, this was the first technology that was certified to remove PFAS. That was done in 2008 through a collaborative study between the Minnesota Department of Public Health and WQA. We determined it was highly effective at removing PFAS. It was generally immune to the chain length, so it does good with the shorter chain, newer PFAS that are being developed, as well as the PFOA and PFOS. You can also use RO to remove a wide variety of contaminants, including other contaminants that affect private well owners like nitrate, arsenic, heavy metals. There are even RO systems that are certified to remove bacteria, virus, and cyst. The membranes, in terms of the maintenance, the membranes last a fairly long time, about 3 to 5 years. There is a pre-filter, which you're going to have to replace once or twice a year. That pre-filter is there to protect the membrane. There's also a post-filter. You're going to have to replace it a similar frequency, and the post-filter is there to further polish the water quality as well as it improves the taste. Now, there is an air gap design for the separate faucet that comes with these systems, so to prevent backflow, but they do come with their own faucet, and they're generally installed at the point of use. There are whole house RO systems, but they're not very popular because two things. First of all, while the RO is treating water, it's also sending some water down the drain. If you're just using it to treat the water that you use for drinking and cooking, that you collect from this separate faucet, it's really not a significant amount in terms of your overall water usage. But if you're using it to treat all the water in your home, then you're sending quite a bit of water down the drain. The second issue is that RO water is corrosive. As it comes straight off the RO, it's corrosive. So when you install them at the point of use under your sink, they're installed with plastic tubing. They go to the separate non-leaded faucet, no problem. But if you install it whole house, you then have to worry about any metallic pipes or fittings downstream from your RO system or even your regular faucets, right? You can install separate treatment downstream of the RO to re-neutralize the chemistry so that it's not corrosive, or you could switch your house over to plastic pipe, or maybe you already have plastic pipe. But that is the second issue, is why they're usually done at point of use. Now, one of the downsides of RO system is that they generally don't come with end-of-life indicators yet. And I say yet because those are being developed. An end-of-life indicator is like a visual light or something that tells you, hey, it's time for maintenance. It's just a really good feature to have if you're a consumer, just to remind you it's time for maintenance. So moving on to carbon, that is one of the advantages of point-of-use carbon filters, is they commonly come with end-of-life indicators, little light that goes off that tells you, hey, it's time for maintenance. Carbon itself is a pretty well-established, proven technology. When we first tested them back in 2008 with Minnesota, they did struggle. But since that time, the carbon manufacturers have come out with formulations that are very good with PFAS. Now, they can struggle with the shorter chain stuff. So back to the need to test your water, another good reason why you need to test your water. If you do have a lot of shorter chain PFAS in your water, maybe carbon is not the best solution for you. These can be installed either at point of use or point of entry. So you could use like a filter on your refrigerator. You can have filters that are installed under your sink with their own faucet, again, that you're using for drinking and cooking. Or you can have more of a whole house system that treats most or all of the water used in your home. One of the complaints we've heard in more recent years is that people are running into carbon systems that leach arsenic at high levels. Now, this shouldn't happen if you're purchasing a certified system. So if it's been certified to any of these standards, then it's been evaluated for whether or not it will leach arsenic into your water. If it does happen, if you do run into certified systems that are leaching high levels of arsenic, then here's some things to try. First of all, look at the literature. Is there a flushing or conditioning step in the literature that wasn't done? So in the product manual, does it say some step about flushing or conditioning? And then second, of course, inform the manufacturer. Third, also inform the certification body, because they all have corrective action procedures they can use to force the manufacturer to fix issues like this. So definitely keep them in the loop as well. Here are the certification bodies. I could talk for about an hour on certification or more. It's become so complex and a little bit confusing, unfortunately. In the interest of time, I can't cover it here, but I will just throw out there This is also an area of my expertise. I started in WQA's product certification group. I'd be happy to answer questions about product certification either in the Q&A or afterwards. So moving on to anion exchange. Anion exchange is also very effective at removing PFAS. These tend to be larger systems installed at the point of entry. So they're going to treat most or all of the water that's used in your home. When you first start up these systems, you can create a temporary rise in the chloride to sulfate mass ratio along with a corresponding drop in alkalinity. Now, what does that mean? It means that if your alkalinity is already pretty low, close to 50, you could drop it below 50, which then combined with the the chloride to sulfate mass ratio puts you in a corrosive condition where you need to now be concerned about corrosion. So this is, again, another great reason you need to test your water. You need to understand the water chemistry. If you're already in a home where you have these low alkalinity conditions, then maybe this is not the best technology to use. But you can purchase buffered versions of these PFAS selective resins so that you avoid that condition at startup, and then after startup, it no longer happens. So it's only a condition that happens when you first start up the system, and there are buffered resins you can use to avoid that drop in alkalinity. But again, maybe your alkalinity is already too low, so something to be aware of. In terms of the proprietary medias, there's obviously, we're still learning about these things. Some of them are just on the market. Some of them have just been marketed and used in products that are available today. Some of them are still emerging. So I thought the best thing I could do is give you some good questions to ask. First of all, what test data does the manufacturer have available? Are there any water chemistry concerns, interferences? What's the lifespan of the media? And if it probably hasn't been tested yet for performance. In other words, maybe they don't have data showing that it's certified to remove PFAS, but hopefully it's at least been tested for material safety so that they can demonstrate that it is in fact safe. It's not going to leach stuff into the water. If you're working with a larger system, like say a trailer park that has a community well, where they need more throughput, they need more capacity, and just more assurance because they have more people involved, you might run into these dual tank systems. So this is a very common configuration in the municipal treatment industry as well. So it kind of started there with the carbon tank. So they would have a lead carbon tank followed by a lagging carbon tank. They sample in between. When the PFAS starts breaking through the lead tank, you put the lag carbon tank into the lead position, and then you put a fresh carbon tank in the lag position. Now, the disadvantage of this configuration is that you will, if you have short chain PFAS present, you will probably never realize the full capacity of those carbon tanks. Because what's going to happen is as you're sampling in between the two tanks, you're going to start seeing the short chain PFAS breaking through. And so then you move the lagging tank into the lead position, you put a fresh one behind it. Well, then the lagging tank is going to start having premature breakthrough of the short chain PFAS. So you never really fully realize the full capacity of those carbon tanks. So what we have seen some of our members experimenting with now is a lead lag configuration with carbon ion exchange. And I've seen this now presented to at AWWA events where municipalities are trying it. And what happens is what you do is you leave the carbon there until you've used up its full capacity. There is breakthrough happening, but it's those short chain PFAS, it's only the short chain stuff, and it's at lower concentrations. The carbon is removing some of it, and that small amount of short chain PFAS has really no impact on the ion exchange tank. So it just sits there. It just stays there in the lag position virtually indefinitely. I've talked to members who have systems like this they've had installed for 3 years, and they're seeing no sign of the ion exchange tank being really challenged yet. And that way, you leave the carbon tank there, right? You're still swapping out carbon tanks continuously, but you're allowing the carbon tank to go to its full capacity. So you do get the full capacity that way out of your carbon tanks. So just something to consider that we're seeing is kind of new. There are also hybrid systems out there that kind of take this concept, and they may have stages built in. So it's like a single system where it has maybe multiple stages. It could be carbon, it could be a proprietary media, and then ion exchange. Like it's multiple stages, and those stages are balanced so that you're getting the full capacity out of each of those stages. Some quick strategies here to help with maintenance on point of use, point of entry stuff. First of all, as I mentioned, look for those end-of-life indicators. That is just a hugely beneficial option to just remind the homeowner, hey, it's time to change filters, time for maintenance, whatever. There are also on the larger systems, internet connections. So you can get systems for point of entry now where it will send a signal to a technician saying, hey, it's time for maintenance over on 500 Prairie Street. Head over there and figure out what's going on, what needs to be changed. And also in warmer climates, you can ask the water treatment professional about installing stuff on the outside of the home so that it can be accessed from the outside. Sort of like your cable box. It's in a secure box, but it can be accessed from the outside. That way, when they have to come do maintenance, they don't actually have to have the homeowner there. So it's just more convenient for the homeowner. This slide gives you some references on disposal regulations for household waste versus commercial waste. I'm not going to try to go into it because it's still kind of an emerging area, moving target at this point. The EPA has said they're not going to aggressively go after passive receivers of PFAS, but yet it isn't always the EPA who goes after people and holds people responsible for liability. So really at this point, nobody wants to accept the liability for potential PFAS disposal. You can use our website to find water treatment professionals in your area that have agreed to abide by our code of ethics. You can also use our website to search for certified water treatment professionals in your area that also agree to abide by our code of ethics. And please support our bill, which is called the Healthy H2O Act. If you follow this link and click on Take Action, this bill aims to provide funding for private well owners and also for small systems to use for testing and for treatment of their private wells. And we'd also love it if you would link to our consumer education booklet, which I have I think 3 copies left over there if anybody wants one. So yeah, feel free to drop by and you can grab one from me. Or you can link to them here. They're free online. These things contain basically general information like I'm giving you now. They aren't going to be any information about specific brands or models. It's going to be general advice for consumers, including different advice for consumers that are on private wells versus municipal water, things like that. And there's also some good questions in there that they should ask before making a purchasing decision. And there's good information in there how to avoid some of the common scams that are out there. And then lastly, Brianna and I are the technical affairs department for WQA. Brianna, if you could raise your hand. We do provide free technical support to government agencies, NGOs, public health officials. Feel free to reach out to us anytime if you have questions on point of use, point of entry. Again, WQA doesn't sell any products, so you can't get products through us. And we cannot endorse a specific brand or model. But we can give you general information like this about the technologies. We can talk about use limitations, help you understand instructions in the manual. We can even help you understand the product certification stuff. So with that, I'll be happy to take any questions. How difficult is the preparation to collect the CycloPure test? I know some require expensive preparation for the collector, no makeup, hairspray, aerosol, deodorant. I think all of those things would still apply. The difference here, though, or one advantage you have, is you're not shipping water. Water, in the world of chemistry, we call water the universal solvent because it wants to dissolve everything, right? It's easy to contaminate water. Once you have that PFAS onto the filter paper, it's much more stable. It's less likely to be contaminated. What is the cost for the PFAS cyclopure testing? Originally, it was marketed at $75. I've heard they raised the price $3. I actually haven't checked lately. So it's somewhere in the $75 to $80 range. And I don't know what the alternate brands are charging, but they're all basically using the same concept. And this concept really is not new. Any of you from the academic world may recognize, hey, you know, academics have been doing this for years with point-of-use filters. They've been using point-of-use filters as data collection devices. The difference here is this startup applied that concept in a much smaller and faster scale. So it's just like taking a point-of-use filter and desorbing all the information you have from it, only in this case, you just have a little cup and you just run the water through it and you're done. How feasible are these options for well owners that have low incomes? Are there any more affordable options or funding opportunities? Well, that's why we would love it if you guys would support the Healthy H2O Act. I think there's a lot of private well owners who simply cannot afford treatment, even the inexpensive treatments like the point of view stuff. You know, there really are some economically challenged areas that rely on private wells. Since PFAS doesn't break down and we are collecting it on RO membranes and filter media, how do we dispose of those? So first of all, you're not collecting it on the RO membrane. What's happening with an RO system is you're diverting the contaminants down the drain. So think about it this way. If you have the RO there, the same amount of contaminants are going down the drain because you're just diverting them from the person who's drinking the water. If you don't have the RO there, they're first going to go in your body, and then eventually, hopefully, you expel them, and it goes out the sewer and ends up down the drain anyway. So the RO system is kind of, it's not collecting anything. It's just diverting it down the drain, so you're not drinking it. The filter medias do collect it. Now, the new media that they developed that's part of that CycloPure test, the reason they wanted to develop that media was what's unique about it is that it can be quickly and easily desorbed. The idea was, let's make a media that will capture PFAS, but then also have a quick method to release it for the purpose of destruction. So that's why they wanted to invent that media to begin with. But as I said with the disposal issue, there are, like if you're a municipality and you're using the carbon tanks to, you know, the lead lag tank to remove PFAS, who's responsible when that PFAS goes in, or that media goes into the landfill? And eventually, if it gets released, who's responsible? That's where the EPA has said, well, we're not going to come after you because you're a passive receiver. You're not the one that caused the pollution in the first place. But it's still an issue that nobody really understands where it's going to go because it's not something the EPA can completely control. They may not come after you, but there are other people that might come after you for those disposal costs. So it is a liability that really nobody understands what the risk is or who's going to end up being held responsible if the stuff that's disposed of does eventually leach out. Now, I will say that with the carbon and ion exchange stuff, from the testing we have done, the majority of the PFAS is going to stay on the media. Like if you simulate a landfill condition, which we have done, what we saw was that most of the PFAS just stayed on the media. So it's not that easy to get off of the current medias. How much time do I have left now? Still good? Is there any discussion in the WQA about making the certifications easier for private well owners to find and understand? I definitely am an advocate for that. Unfortunately, there are a lot of different organizations involved in developing the standards. It's not something we can control. There's a whole consensus process that you have to go through to develop those national standards. And there's a lot of interest in there, special interests who really want to do it certain ways because it does drive revenue for certifications and things like that and listings. So it's not an easy problem to solve, but I definitely think it's a problem we need to solve. It needs to be more understandable. Somebody needs to invent an app or something that simplifies it for consumers. And if anybody has ideas, I would love to help you with that. Are there any solid studies, guidance on potential reintroduction from using RO for PFAS removal when reject water discharges into the septic? The EPA has published a whole graphic on the PFAS cycle, not just specific to RO, but with everything, right? What's happening right now with PFAS? And this gets back to the passive receivers and why all the passive receivers are concerned. What's happening with PFAS is we're really just recycling it back into the environment. It's not being, when we say we're removing it from the water, okay, well, what happens to that? Well, then the water utility discharges it to the wastewater utility. What happens there? Maybe it ends up in the sludge. What happens with the sludge? It gets put on the land and it leaches off again and ends up back in the stream. Starts the cycle all over again. The PFAS isn't being destroyed unless somebody captures it and destroys it. There's really nothing in nature which is going to successfully be able to break down those carbon-fluorine bonds. Those are one of the strongest bonds in chemistry. And so that's why people call it the forever chemical. It's going to remain in the environment until we remove it. Man-made stuff, and we need to remove it. So yeah, I mean, there's all kinds of discussion about how we're just recycling PFAS back into the environment in every application. And we have a graphic on that. The EPA's got a graphic on that. Be happy to share it with anybody if they want to see it. Is TAP score PFAS testing relatively accurate? I believe TAP score uses all certified drinking water laboratories, so I don't think they're doing anything special. I think they're just subcontracting to certified drinking water laboratories. So yeah, it would be absolutely as accurate as any other certified drinking water laboratory. They don't have their own lab. For the non-certified carbon that may contain arsenic, has that been found only in whole units or also in third-party media? I would love to know the answer to that. So I've only heard anecdotal stories of this. Nobody has ever actually sent me a case where we could look into it and figure out, hey, was this carbon certified? Who certified it? You know, what was it certified for? So if you do run into it, you know, would love it if you would keep me in the loop and I could answer that question in the future. Are RO membranes a source of microplastics to the water? I actually don't know the answer to that one. Do you know, Tanya, what the membranes are made of? Yeah, I don't know if they're made of plastics, but. Does the CycloPure testing require a duplicate sample or a lab blank for accuracy? And it doesn't require it, and none of the tests actually require it. It's something laboratories recommend, so I think this would be up to you. Do you want to do a duplicate, you know, to see? If you're initially just testing it out, maybe you want to do some side-by-side testing on your own and figure out what are the results you're getting from a certified laboratory versus the actual CycloPure test. Still have 5 minutes? I should have talked slower. Everyone was worried I was going to run out of time. All right. Are there filters certified to remove microplastics? Yes. It's based on mechanical removal, so size exclusion alone. So basically, they're certified to remove microplastics down to, I believe it's a 0.5 micron. Of course, where do microplastics stop, right? Where does it become micro versus nano? And how small can nano be? Nobody really has come out with a uniform definition of that yet. So I guess you would say they're certified to remove microplastics down to a size of 0.5 microns. How consistent is anion exchange? Is there bypass risk before regeneration? It's very consistent. I mean, all of these technologies are very consistent, and many of them are already certified for removing PFAS. When we do the certification testing, we test all the way beyond capacity of the system. So if it has a capacity of 100 gallons, then it has to be tested to a minimum of 120 gallons, which would be 20% over, or to 200 gallons, which would be 100% over, depending upon whether or not it has one of those end-of-life indicators. So if it has an end-of-life indicator, we'll go 20% past. If it doesn't have an end-of-life indicator, then we go twice as far as what the manufacturer claims for capacity. And that's just to have that extra buffer in there for the consumer. But no, they're all very consistent in terms of breakthrough will happen when you reach the capacity of, when you reach the certified capacity, you are going to start seeing that breakthrough. The difference with carbon is that the certified capacity for those short chain systems is going to be lower because they're going to break through sooner. So that's why I say you never really reach the full capacity of the carbon if you have those shorter chain ones present, because if you didn't have them present, you could continue using that carbon for the longer chain stuff for a lot further. Do you accept requests to ship copies of the consumer booklet? I don't believe we do, right? But you can download it from the website and print it on your own. But yeah, I don't think we have any budget to cover the cost. On some special occasions, we have done that in the past, but it would have to be something you'd have to talk to us well in advance about so that we could get it in the budget. There'd have to be a compelling reason that we were going to cover the cost and things like that. What do you know about biochar destruction of PFAS? I know nothing about biochar destruction of PFAS. I know it can capture some PFAS, but I don't know about destruction. What is the likelihood of PFAS leaching from spent carbon filters? Again, I don't think there is an ongoing WQRF study which is looking at that, but it's not done yet. From the initial testing we've done, most of the PFAS that was captured by the carbon stayed on the carbon. Is there specific filters needed for removal of PFAS, PFOS for RO? I believe this question is asking about, do those pre-filters and post-filters contribute to the removal of PFAS when you're using an RO? And the answer is no. When we certify an RO system for removal of contaminants, we actually remove the pre and the post filter so that they can't contribute to the removal of that contaminant. Now, when you're using it in your home, it probably is contributing some, but at least if you're, the certification is not based on those pre and post filters. Am I still doing okay? One more question. In an RO system, do we know if the two carbon filters are doing all the work to remove PFAS and so on? That one I already mentioned, so I'll skip to that. I'll skip that one. Is there any data on PFAS testing in wastewater and best practices for PFAS removal? Well, there definitely are methods for testing wastewater for PFAS, and it's certainly not our area of expertise, but they're out there. They're also very expensive, just like the ones in drinking water. Is that good?
Thank you.
Thank you, everyone.